Hi everyone. Today we're going to study Gauss Divergence Theorem. Let capital E be a simple solid region and capital S is the boundary surface of E with positive orientation. Let capital F be a vector field whose components have continuous first-order partial derivatives. Gauss divergence theorem states that the surface integral of a vector field over a closed surface, which is called the flux through the surface, is equal to the volume integral of the divergence over the region inside the surface. In symbol, we write like this: double integral over S capital F dot n ds is equal to triple integral over V divergence F dV. This is our working formula. Example 1. Using Gauss divergence theorem, evaluate double integral over S capital F dot n ds, where capital S is any closed surface enclosing a volume V, and capital F or the vector F is equal to 2xi plus 3yj plus 4zk. Let us write our formula for the Gauss divergence theorem. For step 1, let us evaluate divergence F. The vector F is given as 2xi plus 3yj plus 4zk. So divergence of F is this: partial derivative of 2x with respect to x plus partial derivative of 3y with respect to y plus partial derivative of 4z with respect to z. Evaluating the partial derivatives respectively, we have now 2 plus 3 plus 4. So the sum here is 9. This is the divergence F. Step 2, we substitute the value of div F and evaluate. So we copy the triple integral formula. Let us substitute the value of div F. Since 9 here is a constant, we can move this outside the triple integral. Evaluating now the triple integral over E of dv, we have now this 9v. This is the final answer. Now let us take note that for any vector point function capital F, divergence of curl F equals 0. Example 2, using Gauss divergence theorem, evaluate double integral over S vector capital A dot n ds, where capital S is any closed surface enclosing a volume V, and vector A equals curl F. Let us write the Gauss divergence theorem formula. Step 1. Let us now evaluate divergence A. In the problem, it is given vector A equals curl F. So we take divergence A equals divergence of curl F, and this is equal to 0. Step 2, we substitute the value of divergence A and evaluate. We copy the triple integral formula. The div A is equal to 0, and we substitute it here. Because of the 0, the triple integral is equal to 0. This is the final answer. Example 3. Using Gauss Divergence Theorem, evaluate double integral over S vector capital A dot n ds, where vector capital A equals 8xzi minus 3y square j plus yzk, and capital S is the surface of the cube bounded by x equals 0, x equals 2, y equals 0, y equals 2, z equals 0, and z equals 2. Let us write the Gauss Divergence Theorem formula. Let's begin step 1. We evaluate divergence A. We copy the value of A below here, then let us evaluate divergence A. It becomes like this. Partial derivative of 8xz with respect to x plus partial derivative of negative 3y squared with respect to y plus partial derivative of yz with respect to z. Evaluating now, we have 8z minus 6y plus y. We can see here that we can combine the negative 6y plus y. So the final answer, 8z minus 5y. For step 2, we substitute the value of div A and corresponding limits of integration and then evaluate. We write the triple integral to be like this. The dv here is now changed into dx, dy, dz. The div A, we get the value from step 1, the 8z minus 5y. For the first integral here, we write from 0 to 2, and this is with respect to the limits of z. The second integral, the limits are from 0 to 2, and this is with respect to y. And the innermost integral is from 0 to 2, and this is with respect to dx. Now, let us begin the integration, starting with the innermost integral. So the integral of 8z with respect to x is 8zx minus integral of 5y with respect to x is 5yx. Now, let us evaluate this with respect to the limits from 0 to 2. So we have now the first group with respect to number 2 minus, we evaluate the same function with respect to 0. Look at our second group here. Because of that 0, this will be cancelled. We can simplify the first group into 16z minus 10y. Now let us evaluate again the integral from this point. So the integral of 16z with respect to y will be 16zy minus integral of 10y with respect to y will be 10 times y squared over 2. We can cancel this 10 and 2, so we have 5y squared. Let us evaluate this with the limits of integration from 0 to 2. And it becomes like this. The first group, we evaluate the function with respect to the value 2, minus the function is evaluated with respect to 0. In the second group, because of the 0, we can cancel this out. Then let us simplify the first group. Now it becomes 32z minus 20. Let us now integrate the final integral. So the 32z with respect to z is 32 times z squared over 2 minus integral of 20, that is a constant, with respect to z. So we have 20z. We simplify 32 by 2, we have 16z squared minus 20z. Let us evaluate this with respect to the limits from 0 to 2. We evaluate the function with respect to 2, that is for the first group, minus, we evaluate the function with respect to 0, that is for the second group. In the second group, because of the 0, this will be cancelled. Then we simplify the first group. So we have this 64 minus 40, and we have 24 as the final answer. I hope you learned something from this video. See you again next time.